In this video, I am going to solve the problem 23rd from chapter 16, waves 1. The linear density of a string is 1.9 multiplied with 10 power minus 4 kilogram over meter. A transverse wave on the string is described by the equation y equal to 0.021 meter sine of 2 per meter x plus 30 per second t. What are the wave speed and the tension in the string? Actually, this question is exactly similar to question number 4, which we already worked out in the previous video. But in the previous question, we have the linear density in terms of gram per meter. The small changes, but method wise it is exactly the same. But anyhow, we can take some practice. Okay, so we are going to write what is given first. So what is given in the question? The linear density of the string is given as 1.9 multiply 10 power minus 4 kilogram over meter. And the wave equation is mentioned here, y equal to 0.021 meter sine of 2 per meter multiplied by x plus 30 per second t, right? Okay. Actually, this is our amplitude, which is ym, and this one is angular wave number k, and this one 30 is angular frequency. Okay, now in the first part we are going to find the speed, am I right? And we already studied the relation between the speed as well as the angular wave number and angular frequency. So I'm going to apply the rule directly. So A part, we are going to find the speed. We studied the relation v equal to omega over k, right? So now I'm going to take omega value. I'm going to substitute here. What is our omega? Which is 30, and our angular wave number here is 2. So now if you divide 30 by 2, you will get the speed as 15 meter per second. So this is the answer. Clear? In another way also you can find, that is a little bit, some steps will be more. Okay, how we can just solve that better, I can just do that also. That will be easy for your understanding. Actually, we have to compare this equation with our general equation we studied, y equal to ym sine of kx minus omega t or plus omega t. Both are exactly the same. Now we have to compare. So how to compare? Here k is equal to 2, right? Is another method, alternative method. K equal to 2, which is equal to, we know the formula for the angular wave number, which is 2 pi over lambda, right? By that, I am going to find the value of lambda. How to find the lambda? Therefore, lambda equal to 2 pi over 2. I can cancel this. So lambda, which is equal to pi, right? And here in the second part, what I am going to do, I am going to compare the angular frequency. What is our angular frequency? Angular frequency, we know the formula, which is 2 pi f, which is equal to here 30, and I am going to compare these two. So therefore 2 pi f, which is equal to 30, therefore f equal to 30 over 2 pi, right? Now what I am going to do, I am going to use the general formula for finding the speed. Speed equal to frequency multiplied by lambda. So here what is our frequency? We got the frequency as pi, and here we got 30 over 2 pi. So we can cancel pi with pi. If you just cancel this 30 with 2, you will get 15. So the answer will be the same, 15 meter per second. Clear? So you have to see the steps, how many steps we have to do for this method. But if you know this rule, v, which is equal to omega over k, we can get the answer directly. Clear? So you can choose any one of the method. Understand? Okay. Now we have to go for the second question. What is the tension applied to the string? So we are going to find what should be the tension. So for the B part, I'm going to use the relation what is the speed of the wave on the string, which is given by the rule V equal to square root of T over mu. So we are going to find the tension. So you have to squaring on both the left hand side and the right hand side of this equation. By that this equation becomes V square, and in the right hand side the square root will gone. So you will get V square, which is equal to T over mu, where T is the tension, mu is the linear density, where V is the speed. Now we are going to find the tension. Therefore, tension equal to V square multiplied by mu. V square we got as 15, right? So therefore, 15 square multiplied by what is the linear density? You have to go back to the question. Actually, the linear density they give as 1.9 multiply 10 power minus 4. So I have to use that value. Multiply with 1.9 multiply with 10 power minus 4. So let's see what is the answer. So the answer is 15 square multiply with 1.9 10 power minus 4. I got the answer as 0.0427. Better I can write 3 digit as 0.043, and the unit for the tension is Newton. So this is the answer. Clear? That's it.